Okay, so let's see if we can take everything that we've learned and put it together with some applications. All right, so Curtis works for a radio station and the tower for the station stands 200 feet tall. A guy wire 250 feet long supports the antenna. Find the measure of the angle of elevation to the nearest degree. So I went ahead and drew a picture over here. So here's my antenna, 200 feet tall. Here's the guy wire that attaches the antenna to the ground, and I want to know what the angle of elevation here is. So from the ground looking up, what is that angle? So I first want to figure out, am I using sine, cosine, or tangent? Well, I know if I'm situated at that angle, this is my opposite side, this is my adjacent, and this is my hypotenuse. So I'm not using anything with adjacent in it. So if I think about, I have SOHCAHTOA, all right, I'm not using cosine or tangent, so it has to be sine. So kind of like what we learned in class the other day, we have that sine of the angle is equal to 200 divided by 250. So that's the same thing as the sine of theta equals 20 over 25, and we can reduce that even farther and know that it's 4/5. So we talked about being able to look in page 500 and figuring out 4/5. We know that's 0.8. What angle gives us a sine of 0.8? But there's an even easier way to do it, and that's where we talked about that function called the inverse sine. So this is the inverse of sine. Just like cosine to the -1 is the inverse of cosine, and then tangent to the -1 would be the inverse of tangent. Okay, so what's important to keep in mind here is that we're not dividing by sine or cosine or tangent. We're not multiplying or subtracting. Sine is a function. So when we undo it, just like when we undo a square root or we undo a square, we're doing the inverse of that function. So with that being said, we're going to have that theta is equal to the inverse sine of 4/5. And if you plug that into your calculator, the inverse sine of 4/5, we'll see that our angle measure that pops out. Now this is why it's super important that our calculators are in degree mode, because otherwise it's going to pop out something else. So the inverse sine of 4/5 would give us something like 53.1301, and I want that to the nearest degree, so that would tell me that theta is equal to 53 degrees. So that would be our final answer. Okay, so now we're going to consider the regular square pyramid shown. Find the length of the slant height L correct to the 10th place. So L is the slant height, so that's along the side here of this face. So I went ahead and drew in the square pyramid for us, and this is the triangle that we're looking at right here. We know that this is coming down, this is halfway, even though it doesn't look like it. This is 3 and this is 3 since the whole thing is 6. So that's where this 3 comes into play. Where I dropped it down from the point down to the middle, that's H, and then this part right here is L, and this is the angle of 72 that we know right here. So I want to figure out the slant height, so I need to know something about this, given that I know information about this. So am I going to use sine, cosine, or tangent? Well, I have SOHCAHTOA, and I know that I'm right here at 72, so I'm not using the height at all. So I'm not using the opposite. So I can cross off both of those, and I know that I'm using cosine. So the cosine of 72 is equal to the adjacent, so 3 over L. So we multiply both sides by L, and then I divide by the cosine of 72. And when I plug that into my calculator, I get L is equal to 9.7082, and I want it to the 10th place, so that means that my slant height is 9.7. So the important thing to keep in mind is when to use sine, cosine, or tangent versus when we use the inverse of sine. To rewrite that. So inverse of sine, inverse of cosine, and the inverse of tangent. So we use sine, cosine, and tangent if we have an angle measure, meaning that we want a side length. So we have an angle measure, we want a side. When we use the inverse, that means we have all side lengths necessary, and we want an angle measure. Okay, so notice that the inverse, we have an angle measure and we want a side length, we're going to use sine, cosine, and tangent. So if we think back to the two problems that we did today, we had this guy here where we had H, L, and 72. If I have the 72, then I'm going to use sine, cosine, or tangent. On the other one, when we're looking at our angle of elevation, and I want to know theta, and I have my side lengths, so we'll call it H and L, why not? I have these side lengths here, and I want my angle measure. That's when I'm going to use sine inverse, cosine inverse, or tangent inverse. So those are the important things to keep in mind. If we have an angle, we use sine, cosine, tangent. If we want the angle, we use inverse sine, inverse cosine, or inverse tangent.